Hello viewers, welcome to the session on multiple regression in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Before moving ahead, let us understand the definition of multiple linear regression. It is much similar to simple linear regression. The only difference comes at the number of independent variables. Here the number of independent variables will be multiple. So let us look at its definition. Multiple linear regression is a statistical method that allows us to summarize and study a linear relationship between a dependent and always more than one independent variables. Here the key term is always more than one independent variables, and that is how the value of dependent variable is changing with respect to the value of independent variables. So now let's look at its formula. It is much similar to the simple linear regression. Here B0 represents the constant bias factor and B1 to Bn, that is all this Bi represents the coefficients of the independent variables, and the formula is y is equal to B0 plus B1x1 plus B2x2 up to so on Bn xn. Here the coefficients are nothing but the numerical values that tries to bring our actual data set points into the best fit line, and this B0 bias factor always tries to suit our data set points into the best fit line. Even if the data set point is moving somewhere up and above, the constant, that is bias factor, tries to bring it over the best fit line. And let us consider an example. If y is equal to 2x1 plus 8x2, now consider the b2 value is 8 and b1 is 2x1. Then what does it tell? It tells us that the x2 independent variable is more determining the dependent variable than x1 variable. It is the concept of multiple linear regression. The algorithm which we are going to follow in this model is just repetition and the duplicate of what we have done in simple linear regression. So now let us look at the pros and cons of the multiple linear regression. When it comes to its advantages, it has the ability to determine the relative influence of one or more predictor variables to the criterion value, which is the main concept of multiple linear regression. And the second is its ability to identify outliers or anomalies. It clearly tells which independent variable is more determining the dependent variable. Whereas when it comes to its disadvantages, it is often quite prone to noise and overfitting. Okay, before jumping into its practical implementation, let us quickly look at the general path flow of the multiple linear regression. Here also, all the process will be same. The only difference comes at the segregation of the data set, which we are going to segregate on the basis of dependent variable and multiple independent variables. And in the step number 5, we are going to implement our multiple regression algorithm on our training data set. Now it's time for your favorite hands-on session, that is the practical implementation of the multiple linear regression. So I have imported all the important libraries, and then again I have read the dataset. And in this practical session, we are going to predict the profit of an organization whose profit is dependent on the sales within the state, outside the state, but within the country, and the international sales. So here the independent variables are 3 and our dependent variable is 1. We are going to predict the value of the dependent variable based on multiple independent variables. This is the concept here. For this, you have to understand the next line very carefully. Here, what I am doing is segregating my data set into dependent and independent variables, where x is our independent variable. And in this, what I am doing is reading all the records except the last column, that is the profit session, so that it will have all the independent variables. Now I am executing this particular chunk of code and see it has been successfully executed. I have separated the dependent variable from the independent variables. Okay, similarly, I am just putting my dependent variable into the y object. See, it has been successfully executed. I have got all the profit column here in y. Now the same thing, I'm going to split the data set into training and testing data set. Okay, it has been successfully executed. You have seen that I have kept my test size to the 30%. So as a result, the training dataset is containing 15 records. Whereas, testing dataset is containing 15 records and our training dataset is having 35 records. And now I am going to implement mul multiple regression here. It is similar to the linear regression. Only the extent concept here is that our training dataset is having multiple independent variables. Here the extrain is having multiple independent variables. See, 3 independent variables. And on the basis of this, first let me implement this code. Okay, it has been successfully executed. And now I will predict the dependent variable based on our training. See what I'm doing. I'm predicting it. It has been successfully executed. This is what we have predicted for our whole data set. And what is the actual value? The actual value is in y test. Okay, you can familiarize how quite good prediction our was. It was. Okay, let me quickly check its variance score so that you will have the complete idea. So it has been executed with 94% of accuracy. Yes. So as usual, I have included code snippet for your fast revision. You can take screenshot for your quick revision. I hope you have liked this session and hope you have gained something extra than what you were knowing earlier. Thank you.